Hello everyone, my name is Mohammed Zahed Farooqui. I am a final year student in Deccan College of Engineering and Technology, which is situated in Hyderabad. I am making this video for the final assignment of Skyfi Labs. In this video, I am going to analyze and design a tall structure. So in this image, you can see the structural plan of this 23-story building. This is the placement of columns and beams of different stories. From story 1 to 8, all the columns and beams have a similar placement, and 9 to 14 have a different structural plan. So by considering this, we have to analyze and design our building. These are the different size of columns and beams we are going to use in this structure. These are the materials we are using: M40 grade concrete, HYSD bars and 250 mil steel bars. So the first thing, we have to open eTabs 2016 and click on new model. After this, it will show and open up a window. In this, we have to mention our region and type of codebook we have to use. In this, we have to use select built-in settings, select the region as Indian, as I am in India, and select the code books of concrete and steel of that respective country or region, and then click OK. These are the grid line tab. So this can be done by seeing the structural plan of the building. From this we can see that there are 4 grid lines in X direction and 4 in Y direction, and the spacing between them is 6 meters. So for spacing is 6 meters here, and the number of story is 23, and typical story height and the basement height is 3 meters of the structure. So in this, we have to use custom story data for the master story option. In the structural plan, we can see that for different number of stories there is different structural plan. So if we have to make the master story option, click and edit story data. In this, we can see that story 23 is the master story and all of the other stories is similar to story 23. So we have to change as per the set of stories of similar story data. So story 1 to 8 is similar. So I am going to make story 8 as a master story and all other stories similar to story 8. In this, we can select any number of story between 1 to 8 and assign the similar story to that particular story. So for example, I can make story 6 as a master story, and I can select the option similar to for all other stories. So the next set of similar story is 9 to 14. So I'm going to make 14 as a master story. The next similar story is 15 to 19. The next is 20 to 23. 23 is a master story, so we don't have to make any changes in that. So then check the 19 the master story, then 15 of a master story, 14 to 1 to 9, yeah, same story, 8, then click OK. Click on the grid only option and then click OK. So by entering the grid line data, we can get the plan and elevation of the building. This tab shows the elevation of the structure and this tab shows the plan. So basically there are 5 to 6 steps in analysis and design of the structure in eTabs. First, we have to give the material properties. We have to define the material property. The second step is to make the section properties like beams, columns, slabs. Then we have to draw that structural elements. Then we have to assign the loads such as dead load, live load and wind load. The next step is to analyze the structure, then design, and the final step is the detailing of the structure. So the first step is material properties. Add new material. We are region select as India, material as concrete. We are using M40 grade of concrete in this particular structure. Then click OK. Another add new material. select as rebar. We are using HYSD 500 and mild steel bars. Select that mild steel and click OK. So after defining the material, we have to give the section properties of the material. So click on the section properties, then click on frame sections, then click add new property. So in this image we can see that there are different types of columns have been already mentioned. We have to use these sections and analyze and design our structure. So we can see that columns and beams are rectangular sections and the sizes are respectively 500 by 500, 550 by 550, 600 by 600 and so on. To select rectangular section, give the property name as column 500 by 500, material as M40, give the depth as 500 and the width as 500. In this reinforcement section, we have to modify the rebar. We are designing it as column, so click on PM2 M3 design. Longitudinal bars are designed as HYSD bars and confinement reinforcement as mild steel reinforcement. Then we have to check the clear cover for bars, that is 40 mm as per Indian standards, then click OK. In this window we can see that the size representation of the column, then click OK. So we can see that there are different sections of column of different sizes, so we don't have to make this to prevent from these tedious steps. We can use add copy of property. So we have to click on the section, then click add copy of property option, then we can give as column 550 by 550, material will be same 550. I have to give width as 550 again. So we don't have to again modify the rebar option because we have done in this previous property. So by adding the copy of the property, we are making a copy of the property of the previous section, so we can do the work a bit fast. So then click OK, then again add copy of property, then give us column 600 by 600, material will be M40, change the depth and width as 600 by 600, then OK. So we have defined the three sections. So in this structure we are going to use a special property, that is auto select list. This option is used, for example, if we are designing a structure, the software automatically select the section of size. If the section fails, it select the next higher section. For example, it is using a column size of 500 by 500 basically in the first step. If that section fails, it automatically select the next higher section, that is 550 by 550. In the same, this is the very best option. Then property name will be auto select column, type material, select all the columns, then add, and then click OK. So auto select column has been defined. The next step is to define beams, then add new property, rectangular section, give the section name as beam 500 by 300, material will be M40 grade concrete, depth and width should be given, then modify rebars. We are designing it as a beam, so select M3 design only. Longitudinal reinforcement is designed as HYSD bars and confinement as mild steel bars. And as per IS code, the cover will be 25 mm. And click OK. So this window shows the diagrammatical representation of the beam. Then click OK. In the same as column, we can also use auto select list for beam also. So first we have to make the different sections of beam. So click on that particular beam section, add copy of property, and beam of 550 by 350, material M40, that is 550, it will be 350. We don't have to again modify and show rebar because it is done previously. So we have to click OK. Again, add copy of property, beam as 600 by 400, 600, 400. For checking, we can also check the property is same or not. So we can see that it is designed as beam, that is done previous in that previous property. Then click OK and again click OK. So we have defined the three beam sections. Now we have to auto select, give auto select property, add new property, auto select list, then name as auto select beams, add material as concrete, select all the beam sections, then click add, then click OK. So we have defined the properties, and the next thing left is to define the slab section. So click section properties, slab sections, then add new property, give the name of the slab as 150, slab material as M40 grade concrete, thickness will be 150 again, then click OK. Till now we have defined all the section properties. You can see in this image we have made the structural plan of the structure. We have given defined all the properties, we have given the columns and beams. The next thing we have to do, draw the columns, beams and slab sections. To do that, first we have to go to the story 1. So first story 1. Now select it as similar story, then click on draw, quick draw columns. This option can also be selected by the shortcut tab, that is quick draw column. Then select the property as auto select column. Now drag the cursor in the intersection points. The column will be created. Simultaneously we can see the 3D view tab. The column has been created till 1 to 8 story. The next thing we have to do is to draw beams. So click on the draw, quick draw beams. Again we can select from this shortcut tab also. Select the property as quick draw beam, then drag the cursor to the whole plan. Beams has been defined. The next thing we have to do is draw slabs. So section properties, so draw, quick draw floor walls. Then we have to select the property as slab 150. Then we have to drag through that, and the thing is done. So this is the first set of similar stories has been done. So in the next set of similar stories from 9 to 14, the structural plan is different. So by seeing this, we have to design, we have to draw the sections from 9 to 14. So by arrows go to the ninth story and see the structural drawing. We can see that this section is left out and this section is left out. So based on this drawing, draw the sections. So again, instead of going from there, I am going from this, quick draw columns. So again, quick draw beams. We have to select the property once only. The next thing we have to quick draw slabs. So the thing is done. We can go to the next set of similar stories. That is 15 to 19. In this we have to draw again columns. So first see the structural plan. Okay. Then draw beams. and quick draw floors. Then again go to the another set of similar stories, that is 20. See the architecture structural plan. Okay, then again quick draw columns, again beams, then slabs. So after giving all the properties, go to the basement floor and select all the joints and assign as a fixed joint, restrained as a fixed one, and click OK. So after defining and giving all the section properties, now the next step is to give the loads. We can see in this image that that load is same for all the stories, all the similar stories from 1 to 23. That dead load is 2 kilonewton. So go to the plan, story 1, click apply, then OK. Change the option from similar stories to all stories, as because the dead load is same for all stories. Then select the slabs of story 1. So software will automatically detect that in that particular region the slab section is there or not, as because in our story 1 they are all slab panels, but as we go upstairs there is no slab panels at the corners, so the software will not assign the load there. Then after selecting the slab panels, go to assign, shell load, uniform. The dead load will be 2 kilonewton and we have to select the dead load, apply, close. We can see that dead load is applied in all stories. The next thing we have to do is assign the live load. So go to plan, story 1, apply, then click OK. As we can see in this image that the story 1 to 8 have a live load of 5 kilonewton. So select the slab panels of story 1 and go to assign, shell load, uniform load, change the load pattern to live, load as 5 kilonewton, apply. Okay. In the next set of similar stories, oh sorry, we have done a mistake here. We have forgot to change the option from all stories. So click on story 1, OK, select the slab panels again, assign, shell loads, uniform load, delete the existing load and click apply, close. So we have to assign the load again, go to story 1, change the option to similar stories, then click on the slab panels here. So we can check if the dead load is still remaining or not. Display, load assigns, shell, apply. So we can see that the dead load is still been in the whole structure. The thing we have to do is to define the live load. So again story 1, plan, story 1, apply, close, then change the similar stores, click on the slab panels, then go to assign, shell loads, uniform, change it to live load, load is 5 kilonewton and click on apply. So the thing is done. Go to the upstairs next set of similar stories and again click on the slab panels, assign, shell loads, uniform, and the load for next similar story is 4.5 kilonewton. So we have to mention 4.5, live load, apply. Okay, so next set of similar stories will be 15. Select all the slab panels, again go to assign, shell loads, uniform, the load value is 4 kilonewton, apply. Okay, Go to next similar story, assign shell loads uniform. Say the load is 3.5 kilonewton. Apply, close. Till now we have assigned all the dead load and live load on the slab panels. The next thing we have to do is to assign a cladding loads. Cladding load is applied on the external beam that the load is 0.2 kilonewton. For this we have to select the external beams of the all stories. We can do by keeping the option as all story because external beam varies for different set of floors. So go to plan, story 1, apply, okay. Then select the external beams for wall load. Then go to assign, frame loads distributed, dead intensity is 0.2, and apply, okay. So go to next set of similar stories, select the external beams, so select it carefully because if once it is done wrongly done, the load will be wrongly distributed. Again click on assign, frame loads distributed in 0.2 dead, apply, okay. Next set of similar stories, we have to select external beams for wall loads, then assign, frame loads distributed load 0.2, apply, okay. So last set of similar stories, click on assign, distributed, apply, okay. So till now we have assigned all the loads, we have defined all columns and beams, materials has been done, slabs has been done, cladding load is given, dead load, live load of the whole structure is done. So we can see in this that at story 23 there will be no wall load. So go to story 23, change from all story to single story, display and deform shape, one story, go and select the external beams to remove the wall load from the top floor. Then go to assign, frame loads distributed, delete the existing load, apply, close. So till now the work is done. Then go to the plan view of story 1, apply, close. So we can see that 0.2 kilonewton is distributed on the external walls. So next thing in the assigning of load is we have done the dead load, live load, and the final load to be applied is live load. Sorry, wind load. For applying wind load, first we have to define the wind load. So go to define, then load patterns, type as wind, select the type as wind again, select the codebook which is used for designing of wind analysis, that is IS 875 1987. Then click on add new load, then again click modify lateral loads. In this window at the left part we don't have to make any changes. On the right part we have to enter the value respect on the respective region. For example, wind speed, terrain category, structure class, K1, K3 constants, etc. We are considering the building is constructed in Bangalore, so wind speed VB for Bangalore region we have to check it in the IS 875 part 3. So we can see in this map that basic wind speed for Bangalore is 33 meters per second. So go to the software, enter 33. So next is terrain category. So here is the terrain categories. In the clause 5.3.2.1, Bangalore will fall in the category 3, having a size of building structures up to 10 meters in surroundings, with few isolated tall structures. So write as category 3, structure class. So go to structure class clause. Yeah, here is the structure class. Bangalore will lie, our building will be in class 3 because it is saying that greatest horizontal or vertical dimension should be greater than 50 meters. In our case, our building is 23 story, so 23 into 3, that give rise to 69 meters in height, so it is greater than 50 meters. So select class 3 and risk coefficient factor. From table 1 we can see that all general building sectors with life of 50 years, wind speed 33, the value of K1 is 1. So already in same, and the value, the last value K3. So we have to go to the clause again to view that. I think it is 5.3.1. Yeah, here it says that value of K3 will be 1 and the slope is less than 3. So in Bangalore, the slope is less than, the wind slope is less than 3, so value of K3 will be 1. So here we don't have to change these settings, then click OK. We have defined the wind load. The next thing is to assign the wind load. To assign it, first we have to draw the claddings. So go draw, select auto draw cladding, use floors, and click OK. The cladding has been done. So I don't want to see that that's a uniformly distributed cladding load. So go to display, undeformed shape, that is done. So now we have to assign the wind load. First we have to view the elevation of the left side. To click on section A, apply, close. Now we can select the claddings, change to all story options, select the claddings, sorry, all stories. I will do the selection again, then go to assign, shell loads, wind pressure coefficient. So to get that wind pressure coefficient we have to use codebook. So in codebook there is a specific table that gives the wind pressure coefficient. For this, first we have required building height ratio, that is height by width. Our building height is 69 meters by width is 18, so the value will be 3.8. It is greater than 1.5, so it is lied in this section. So then length by width ratio, that will be 1. So I think we are using this, so that data will be 0, the A value will be 0.8. So it is windward direction plus 0.8. Then click on apply. Then okay, as we can see that our building is exposed to the at different section. In section A, this part of the building is exposed, and again in section B, this cladding is exposed. So we have to again select, go to elevation and select on section B, and then click on apply. Okay, select the claddings, then again assign, shell loads, wind pressure coefficient, we don't have to change that value, then click on apply. Okay, so we can see that we had applied all the wind loads in left side elevation. Now at right elevation, so click on D, apply. Okay, select all the claddings, sorry, assign, shell loads, wind pressure coefficient, the value of coefficient, again go to codebook. At B the value is minus 0.25. So mention the value of CP minus 0.25, then click on leeward direction, because then click on apply. Okay, so again we have to select the section C because it is also exposed. Section C, apply. Okay, select the claddings, then again go to assign. Shell loads, wind pressure coefficient, the value will not change. Apply. Okay, we have done the left elevation and right elevation. Then we have to do front and back elevations. So go to the elevation, select elevation 1, apply. Okay, so we can use the coefficient that we can see that the value of DC is minus 0.8 and minus 0.8, the value is same. So we can select all the claddings at once only. So select the claddings of every section 1 2 3 4, because the value are same. I'm going to number 2, then number 3, number 4. The software will automatically see that the outermost section of the building and assign the load direction in that way only, so we don't have to take any attention regarding that. Click on assign. Shell loads, wind pressure coefficient, the value is minus 0.8 in leeward direction. Apply, close. To check the we're done, so click on plan, click on story 1, apply, close. We can see that we have selected the top front elevation and back elevation at the same time, but the direction is right because software will automatically detect the outside and outer edges of the building. So see the another set of sections. Yeah, this is done. So next thing, after giving wind load, we have to the two main steps remaining is analyze and design. So first we have to define the load combinations. Go to define load combinations. There is no combination. Add default design combos. Select concrete frame design and click OK. Then click OK. So we have to now analyze our structure. So click analyze and then click run. We have to check the load is an action status. Run and then click run now. First we have to save the model, so I am going to save as final assignment Skyfi Labs. Click on save. So we can see at the bottom that the analysis is done. As the structure is tall, it takes some time, but we have to wait. The analysis has started. We can see in this. So analysis is done. After analysis is done, we can see the various shapes that bending moment stresses diagrams. So click on display, then click on frame piers. I want to see shear force, then click apply. These are the shear force diagrams. Then I want to see moments, then click apply. These are the moments. In the same way, we can also see the stresses on slabs, then click apply. These are the stresses. Close. By this we can analyze our structure. The next step is to design. So click on design tab, click on concrete frame design and check the code book you're using. Yes, it is IS 4562,000. Then click OK. Again click on design, concrete frame design and start design and check. As the building is large, it will take some time. we can see that it is saying that 705 sections frame. As we have used auto select option, it has used the basic values. For example, for column it has taken 500 by 500 section, and for beam 500 by 300. By taking that section, 705 concrete members are framing. So by clicking yes, it will take the next higher section. So click on yes. It will again analyze the model and again design, then again check the design is successful or not. As we can see that it is saying that one concrete frame is failing. By allowing, it will take the next higher section. So you click yes. It will again analyze, design and check the sections. It is again showing that one concrete frame fails. Then click again yes. So now we can see that our structure has been passed. For again checking that, we can go to the design, concrete frames and click on verify all members passed. So it is going a notification that all concrete frame passed the design check. So after that we can view the reports, that is project report, summary report. It will take some time to generate the summary report, but I am clicking it. So it contains all the summary of the project, the types of loads applied, the material used, the sections of the materials, design combos, and all. In this we can select that all the things. It also gives the base reactions, moments, shear force, shear depth, and another things. So now I'm going for detailing of the structure. Then click on detailing and start detailing. After detailing has been done, we can view detailing in this detailing tab in Model Explorer. In this we can see the floor slabs details such like that. This is the slab details. We can also see the column details. It is the floor column plan, column layout plan, reinforcement cages, drawing sheets. This is the drawing sheet, reinforcement and all. So we have done the analyze, design and detailing of the G plus 23 structure. So I want to show you the extruded view. Okay, I think it will not work now. So thanks for watching. Thank you.